we can implement a rootkit in an Oracle system package. And Pete mentioned this in his talk before. All the Oracle packages are wrapped and obfuscated or encrypted, depending on the Oracle documentation. And there are also working PLSQL unwrappers out there. And with these PLSQL unwrappers, you can unwrap a PLSQL package, backdoor the package, then you wrap the package again and install this backdoored package in the database. And the normal DBA without this unwrapper has no possibility to find this backdoor. So here is one of the unwrappers available. Here you can specify the package on the file system, then you specify the type, and then by clicking on the pass button, you get the source code of the entire package. And now in this package, we can implement our backdoor. One of the procedures of the DBMS output package is the procedure enable. With enable, you can enable the output of the database. And in this case, we add some code and we say, okay, if this package is executed on a Saturday or on a Sunday, we grant DBA privileges to the user Scott. On normal work days, we revoke the DBA privileges from the user Scott. And then we wrap this package again, install it in the database, and then during the week, everything looks fine. Everybody has the right privileges. And only on the weekend, the user Scott has DBA privileges. And most of the security audits are done during the normal business hours, so it's quite difficult to find such a kind of backdoor in the database. The only possibility to find this are checksums. So similar like Tripwire, you need a tool to do checksums in the database. Yesterday I had a discussion with Pete, and he had also an interesting idea, and I included it in this presentation. He called it port locking. By sending a special string to a package, you can activate the Trojan on the system, for example, to create a reverse shell. And this is quite easy to implement. So here the same package, the same procedure, enable from DBMS output, and here we say if the buffer size is 31337, then we are modifying the password of the user Scott and grant DBA privileges to this user. And in all other cases, we revoke the privileges. So by sending one special parameter to a database package, we can activate the backdoor. We could also implement the reverse shell. We could start operating system commands, stuff like that. And also, again, wrap the package, install it in the database, and during a normal security audit, nobody will find it. This is quite useful if a hacker works on an unpatched database. So in this case, he can install a backdoor, and if the database is patched in the future and the security vulnerability is fixed, he has still the possibility to become DBA on the system. Any questions so far? Second generation. The second generation is a little bit more difficult to implement, but also more difficult to find. Sometimes you need special accounts to be able to find these modifications. Because in Oracle you have different groups, and only the sys account is able to see all the data and all the information unmodified. Oracle has some functionality called virtual private database, and virtual private database is able to modify select statements afterwards. So you run a select staff from table, and Oracle automatically adds a where condition. And this can only be deactivated by having a special privilege, exempt access policy, or if you are a sys. I found different ways to implement a second generation rootkit. So this time we don't modify a view. We are trying to implement a modification without modifying the data dictionary, where all the packages and views and stuff is stored. The first idea, it's quite easy to implement, is we can implement a rootkit by modifying the binary. So what happens during a normal login process? The Oracle executable is looking in the table sysuser$. Then he reads the username and the hash value and compares this data with the login data. The question is, how does Oracle know to look up in the table sysuser$? It's quite easy, it's somewhere written in the code. I'm not a reverse engineering expert. I'm using the poorest man reverse engineering tool called UltraEdit. So just by opening the Oracle executable in a text or hex editor, you can search for the string sysuser$. And in Oracle Express Edition, you have 106 occurrences of this table. And then I used the simple trick. I said, okay, replace sysuser$ with sys.aser$. And then replace everything in the file and then store the file. Now if you log on to Oracle, Oracle is no longer looking in the sysuser$, Oracle is looking in a totally different table, aser$. And if the old table still exists, the security auditor or the consultant or security tool is looking in the wrong table. So it's looking for a new user in sysuser$, but this does not work, or the user is not available. But if you log on with this hidden user, you are accessing a different table. So here we create a table. Then it's important, before we do the modification, we must create a copy of the table sysuser$. If you don't do this, you're not able to log on to the database anymore. And after creating a copy of the table sysuser$, we've create table sys aser$, as select star from sysuser$. We are dropping the user hacker from sysuser$. So now we have one row more in the new table. Then we shut down the database, and then we replace the name of the table twice. And then after doing this, we can log on to the database, because Oracle is looking in the new table. But all the tools and all the security auditors, they have the sysuser$ or the view hard-coded. So in this case, we don't have a modification in the data dictionary, and we have an invisible user. And here again, the way how to do this, create a user with DBA privileges, create a copy of the table. Then we drop the user hacker from the old sysuser$ table, and we shut down the database, patch the binary, and start the database. The protection is quite simple, but Oracle must do it. One thing is Oracle should sign their binary files. So as far as I know, is someone from Microsoft here? Microsoft protected their binary files, so you are not able to modify these binary files by patching them with a text editor. And I would also recommend to get rid of all the clear text SQL statement in binary files. Normally there's no reason that you can see a simple select statement in a binary file. And using this technique, patching SQL strings in binary files, you can also hack a lot of databases if you do this modification on the client side. Then you should use checksum tools like Tripwire on the operating system to find modification. And here it depends on your level of paranoia. So if you're working in a high critical area, I would recommend to do this. And a few minutes ago, before the talk started, Pete mentioned that Oracle is now delivering tripwire with the database. Is this true, Pete? No? Okay, so we will check this out later. And you should also harden your database, because if your database is hardened, then it's much more difficult to become operating system access. And you should also check your binary files after you have a new DBA. For example, if your old DBA is gone, then you should check the entire system for modifications, because you cannot never guarantee that there's no backdoor in the system. The second possibility, so in this case, we are modifying the binary files. And there are many other possibilities. The second possibility is called PLSQL native. Since Oracle 9i, there's a new feature called PLSQL native, and this allows to convert PLSQL code into C code. This C code is compiled on the operating system level, and the result is a DLL, and Oracle calls this DLL or library instead of the original PLSQL package. And the problem is Oracle does not monitor the files in the file system. And in 10G, these files are stored in a CLOB field in the database. In 9i, this was also one of the easiest way to run operating system commands. Because by using alter system command, you could specify the name of the make utility. So by using an alter system set PLSQL native make utility, if you set this value to calc, then every time you compile a PLSQL program, the Windows calculator pops up and tries to compile the binary. And in 10G, this was changed. Now in 10G, Oracle is retrieving the compiler information from the registry or from the environment on Unix. And then the compiler syntax is stored in a text file, spnc_commands. And this is the command, this command is executed, cl.exe, %source, no logo, and so on. This is also a possibility to implement a backdoor if you replace the cl.exe with something else. This command is executed. So if you replace this with a shell command or a format command, this is executed if you run PLSQL native. Okay, how does it work? First, you must set, if PLSQL native is enabled, you must set the compiler flags with the alter session command to native. And then if you create or if you alter a procedure, Oracle generates a C file on the operating system first, and this C file is compiled into a DLL. And here's an example of such a C file. It's quite unreadable, and I'm not aware that people had a deeper look in this. And this is executed, and this is this PLSQL code from the package.